Good afternoon, everyone. We're going to dive straight into our third talk of the day. And it's a real pleasure today to be able to introduce Mark Enzer. Mark's the strategic advisor for Mott MacDonald. He's a keen champion of outcomes-focused thinking, collaborative delivery models, digitization, connected digital twins as a headline, and the circular economy in the built environment. So as strategic advisor at Mott, Mark provides advice to key clients on digitization and broader industry transformation. And today, Mark's going to talk to us on data and digital innovation with a purpose. He'll discuss the importance of breaking the status quo of siloed working by using systems-based solutions. So, without further ado, over to you, Mark.
Thank you very much. It's a real pleasure to be here. Great to see you. I've got way more slides than I have time to go through, just to get it out there. But this is intentional, because then it can give you a little bit of a chance to kind of direct me where you would like to go. So what I'm suggesting to do is to set a bit of context, because if we're talking about digitalization and doing it with a purpose, we kind of need to know what the big purpose is. It's like, what's the reason? What's the big why? So I'm going to do that context anyway, irrespective of what you say. However, when it comes to the next bit, the digitalization, we can spend a little bit longer on that, if you like, a little bit less long, depending on kind of what you're interested in. If you want to kind of go over some of the kind of the core basics of what digitalization is and what we have to do at a national level, or maybe you're more interested in digging into some details around digital twins, like what are they, how do they work? You've heard about them, but let's kind of find out what they are. And then there's also this thing at the end, the National Cyber Physical Infrastructure and AI. So with the digitalization stuff on number 2 there, it's all kind of now stuff. It's with us, and it's useful, I think, to dig into it. On the National Cyber Physical Infrastructure and AI, it's kind of future stuff. And so I can't kind of give you examples and say, this is where it's been done before. But what I can do is point to where I think it might be going. Okay, so we can't do all of that. And I'm just going to take some kind of indications from you as to where you'd like to go. But let's first do the context. Because like I say, this is non-optional, because I'm very keen on it. I like to tell the big story. So the first bit is to talk about our system of interest. It's like, what are we talking about? And I think that what we're talking about is the built environment. Now, the built environment is amazing. Let's just think about it for a moment. You've got the economic infrastructure, so that's our energy, transport, water, waste, telecoms. Now, each one of those are complex interconnected systems, but they're getting more complex and more interconnected, and particularly because of the move towards net zero, decarbonising the grid. So, for example, the transport system does not work without the energy system. The energy system does not work without the telecom system. These things are completely interdependent, and you can get these massive cascade failures potentially, where one thing goes down and knocks the whole of the rest of it down. So it kind of matters. And then there's the social infrastructure. So that's our hospitals, prisons, schools, but also commercial, residential, industrial buildings, the kind of stuff that people around here work on. Now, none of those make sense or even work unless they're plugged in to the economic infrastructure that we just talked about. And that's not the end of the story, because there's also the interface with the natural environment. So the natural environment is a complex interconnected system on its own. But the thing is, there's this really interesting interface between the built environment and the natural environment. So you add all of that stuff up together, and you get the built environment. That's what we're talking about. Now, the thing is that very often we don't even notice it because we live inside it. It's like it's hiding in plain sight. But this built environment is an amazing organism that our society completely depends on. If the built environment doesn't work, then society falls to pieces. Like this is massively important. So the first thing I just want to get on the agenda is to say that the built environment is a system of systems. You might not like the language of systems, and it might sound all highfalutin and theoretical. I just want to say it is. That's what it is. can't get away from it. It is a system of systems. So let's deal with it like it's a system of systems, because we've got a massive issue that the organizations that run the built environment come from the 19th century when it was okay to work in silos. It's not okay anymore. The organizations and the institutions that we now have to run this complex, amazing system of systems that we utterly depend on, they're a few hundred years out of date and they're not connected. That is a problem. And so if that's not enough of a burning platform for us to do something about it, I would say we don't just have a burning platform, we've got a burning planet. You know, there's this whole thing that climate change is real. I guess we're kind of almost getting fed up with it now, aren't we? Hearing month in, month out. It was the hottest February ever for 2 million years. It's like, seriously? You know, this matters. But the thing is about climate change is it doesn't just happen in silos. It's a challenge which is joined up. And if we just dig into that, there's a few other challenges which are also joined up. So achieving net zero, or providing some kind of climate resilience, or moving towards a circular economy, or providing some kind of infrastructure equity, protecting biodiversity. You know, these are big things, but they affect the whole of the built environment. This affects the whole system. So what I'm saying here is that we've got joined up challenges as well. So we've got joined up systems, we've got joined up challenges, but we've got disconnected organizations. And then crucially, if we're talking about data and digitalization, we've got disconnected data that the organizations need to address these kind of problems. So let's just summarize that. We've got connected systems that we rely on, connected challenges which affect the whole system. We've got disconnected organizations that are meant to be running them, and we've got disconnected data that the organizations need. I'm saying this is a massive problem, but digitalization can help. You know, we have to do something about this. This is not just a crazy guy standing here ranting. Well, maybe it is, but there's some truth in what I'm saying. We have to do something about it. And if we look back then at the built environment, because that's our system, that's what we can deal with, you know, we have something to do with this, we can see that the built environment has a part to play in this. Did you know that a year and a bit ago, there was a tipping point we reached where the total mass of the built environment exceeded everything, the mass of everything that's living. So you add up everything, all the trees, the bacteria, the humans, the cows, the plankton, everything that is living, it's a lot of stuff. Now the built environment outweighs it. The built environment also is accountable for something like 70% of carbon emissions. The built environment also is the biggest user of natural resources. Out of all human activity, the built environment takes the most natural resources. So what that means is the built environment matters. And then I would say that means so do we, because we're the ones who can do something about it. There isn't anyone else, you know, like we are the people who work in the built environment who can do something about this. I'm kind of saying we have agency. Even though I painted it like a really big picture and it's really big and scary, the thing is we can do something about it, so we need to step up and do something about it. And that's where I think digitalization comes in. This is not just a nice thing, you know, something you do because it's fun or because, you know, we were good at tech at school. You know, digitalization actually matters to solve the big problems. And so what that I think means is that we need some kind of unifying vision. We need to know what we're aiming for. If we don't know what we're aiming for, we can't get there, can we? And so I would suggest that we need to see that the built environment itself has a purpose. And that purpose is to enable people and nature to flourish together for generations. That might sound a bit like tree hugging, but actually it is just simply a statement of sustainability. If we want to stay on this planet and survive, that's what we have to do. And that's all summed up quite nicely in this paper. So Google it, have a look at it. I think it's really good. It's called The Vision for the Built Environment. It's a really easy read. It's not academic. It's only a few pages long. It's got lots of pictures. It's quite good. The thing is, you might say, that's a whole load of theory, and it's nice, but come on, what are we really doing about it? And what I would say then is, have a look at this. Transforming Infrastructure Performance 2020. This is government policy, and just do it. Look it up. Google this and Google the vision and see how close they are. Because this was built directly on that vision. It's not just theory tree hugging, this is now government policy. And you can see the way they articulate that same model, aiming for big outcomes, recognizing the role of the systems. You have to understand the systems, intervene more effectively. So it's not theory, this is something that we have to get involved in. And I think that at the heart of this approach, it is a systems-based approach. I have a feeling that all of us will be hearing a lot more about systems thinking as we go forwards, because that's what we need. It's an outcomes-focused systems thinking. And so what that's all about really is start with the end in mind. What are we trying to actually achieve? And that can be summed up quite nicely with the SDGs. But the SDGs, the Sustainable Development Goals, they're kind of global. They feel kind of far off. And so one of the things we have to do is make it local, get the alignment down, so that we've got objectives and outcomes we're aiming for, not just global, but national, regional, local. If we have that alignment, then it works. Because obviously, if we're doing stuff locally that doesn't align to the SDGs, we will never achieve the SDGs. It's got to align. It's kind of obvious, isn't it? And then let's look at what we've got to deal with. What are the levers we can pull? Well, it's the systems, isn't it? And because we work in the built environment, that's what we can do. These are not the only systems. There's obviously social systems and economic systems and legal systems, all that kind of stuff as well. I buy that. But this is what we can deal with. So we need to understand it, don't we? And in the built environment, there's a whole bunch of processes that we're all involved in. We might not be involved in all of those processes, but we're involved in some of them. Ideally, they should be joined up. I think the most important one is use, because that's where we get the value from. And why is it that whenever I see a process of what the construction industry does, it never includes use? It usually starts with planning and it ends with construction. But what about integrating it into the system and making sure that the whole system works? And more importantly, what about the use? Does it actually work and deliver the outcomes that we want? So we need all of those. And it doesn't matter where you're working in those, you have a part to play. And digitalization does. Because I think crucially, in all of those processes, so you probably can't read it, use, operate, maintain, plan, design, build, very familiar. There's decisions. And what digitalization, I think, fundamentally is about, is making better decisions faster. If we do digitalization and we don't end up enabling better decisions faster, then we have failed. There was no point. It doesn't matter how nice the software is, or how wonderful the computer looks. If we're not delivering better decisions faster, then we've failed. And I'd also say it has to be community enabled. It has to be joined up. And I'll come back to this point later on, because basically, if you have one part of the supply chain going digital and the rest isn't, it doesn't mesh, it doesn't work. We've got to work together on this. Okay, so as if just to ram the point home, forgive me, I think that currently the industry works to this view of the world. You do a project, you get an outcome. But we've just spent, 20 minutes or something saying it's not like that, is it? The way it really works is like this. The projects we work on are interventions on the system. The outcomes come from the system. So we have to understand the whole system. And if we just put it in scale for a moment, in this country, we have 99.5% of the built environment that we need already. We've already built it. We've been building it for years. Each year, we add 0.5% to it. That 0.5% really matters, because the industry is worth something like 9% of GDP. Like, it really matters. But let's just put it in scale. That's what it looks like. I've done the calculations. That is it. That's 99.5%, that's 0.5%. So my argument is that if we're going to do digitalization properly, we have to do it to the 100%. Let's not just think construction, let's think the whole built environment. That's how we will get the value. So please, think beyond construction. Construction is massive, it's hugely important, but there's more than that. Okay, so let's just have a quick example of that. Everybody knows that construction productivity is woeful. and we have to improve it. It's true, we do. We have to improve it. However, just think, what are the big outcomes we want? The big outcomes we want are actual national productivity, which is also woeful. And then just think, if we're going to make the biggest impact on national productivity, is it by increasing construction productivity? Or is it by increasing the performance of the infrastructure? I mean, just imagine what it would be like if we had a transport system that actually worked. You think what the impact that would be on national productivity rather than just construction productivity. So my argument here is not that construction productivity doesn't matter. It does. I'm saying that there's a bigger picture and we have to address both. It's not either or, it's both. Okay. That was the preach over. I'll get off my soapbox, but it's like you needed to hear that. I hope you like it. Does it resonate? Does anyone get that? Are you happy with that? We've got one gentleman here who wins the prize. Okay, now we're into digitalization. And this is where the choice comes for you because we're not going to get through the whole lot. So would you prefer to hear kind of some high-level stuff about what digitalization is? Or would you like to dig into some details about digital twins? Or would you like to hear about the future cyber-physical infrastructure and AI? So you've got three choices, basically. So show of hands, the general digitalization. Who wants that? 2 people. Okay, who wants digital twins? That's a reasonable showing. And who wants the future stuff? Okay, super. So what that means is we'll be really quick. We'll scoot through it super quick on the digitalization. But I have to get past the slides. Okay, so the first thing was, I reckon that this is what digitalization is about. It's about people. It's about enabling. Information processes technology. It's not just technology, folks. If anything, it's more about information. Information value chain, super important to understand. Processes and information flow. Oh, you're glad you didn't choose this, aren't you? This is where it becomes a little bit more realistic. It's kind of saying information is value. If we drop the information on the floor, we're losing value. So in between these processes, for goodness sakes, let's get something that flows through. And it's saying if we want to digitalize, the stuff we have to digitalize is all of those processes. Also, all of this kind of chain, this machine. And this is where I was going to say, if a contractor, one contractor, a brilliant contractor like Mace, for example, who we just heard from, if they go completely digital, but nothing else is digitalized, it doesn't work. So you've got to digitalize the whole thing. And that means it needs to be joined up. And if you're going to digitalize the whole thing, let's work out how to do it. You can break it down into various different bits. And my argument here is that what we have to digitalize are our projects, also the systems which we touched on, but also the organizations. All 3 of those need to be digitalized, otherwise it doesn't work. And here what I'm saying is that it's really good to push the front end forwards, but actually the biggest challenge for our industry is adopting the good practice that already exists. That's what we really need to focus on. But that's boring, isn't it? Because what we want to do is focus on the new stuff, exactly like you do. So what that's just describing is just a typical change thing. And really where the change has to happen is in the big blue blob. There's good models for how to drive change. This is what the Infrastructure Client Group does. It's really successful. And if you were interested, we can come back to it in the questions. There's something which I think is really important. We call it progressive integration, which is kind of saying you can't change everything all at once, but we know that integration is needed. So why not start with some simple stuff? Like work out how to make a CDE, common data environment, actually work. So you don't start with a blank sheet of paper every single time. And then not just have a CDE for delivery, also get the digital PMO to be connected to it. Let's start with some simple integration. And then we can imagine some future integration, like integration into the AM, FM world, asset management, facilities management, also into the operation, the maintenance and use. We need integration across the whole picture. So let's just start with some simple stuff. There's some really good guidance to help with this. You might be aware of the Data and Digital Principles for Project Success. It came out from the Infrastructure Client Group. They're really nice, they're really simple, and they're not in digital language. They're for everyone to get access to. So have a look at that. It's really worth looking at. You can see what the principles are there. And of course, we have to think about security. Maybe we want to come back to that in questions too. Amazingly, the digital twins have disappeared, which is really disappointing because you chose the digital twins, but I can still talk about them. And it might even save us time if I don't have the slides. So I'll try and do it by means of interpretive dance instead. I'll move my arms around a bit. Okay, so the basis, the absolute basis for a digital twin is that it makes a connection between digital and physical. That's the essence of it. And so if you can imagine a kind of a physical thing, let's imagine a Formula One race car. In the pit lane, there's a digital version of that. You might be aware of it. And the digital version is fed with data from the car. And the car is bristling with sensors. Even the driver has got sensors on so that you know what his perspiration rate is. Usually it is a he, I'm afraid. But also the reaction time. You can understand how hydrated the driver is. All of this feeds in to the digital version so that the people in the pit lane can understand what's going on and can generate some kind of insight to make good decisions on the race. And that includes fuel management and tire management, all of these kind of things. And so you have this two-way connection. Yeah, if you could just get it back up to here, that one. So you have this two-way connection. Basically, it's data going one way from physical into digital, and then you've got some kind of intervention going the other way from digital into physical. It's this two-way connection. That is a basic digital twin. Now, the key thing is, I think, that a digital twin is really about a methodology rather than a technology. It's an approach. So you will probably hear lots of people saying very detailed definitions what a digital twin is. I would kind of leave that to one side, because the more important thing is the benefit of digital twinning. And in digital twinning, there's loads of things you can do. And it kind of integrates many different technologies. So let's just consider some of the technologies which get integrated. To get some of the data from the physical environment, there's loads of sensor technology. But then to get from the physical into the digital, you can see lots of comms technology, IoT and 5G. And then in the digital world, there's digital platforms to consolidate data, bring data from many different places. Also, inside the digital twin, you can imagine various different types of models. AI-based models, agent-based models, physics-based models. And then also, us humans need to see inside the digital twin, which is where visualization comes in. So that's where you get AR and VR and MR. And so what I'm describing, kind of going around the loop, is lots of different technologies which you can use if you want. You don't have to have all of them, but you can integrate them in the context of a digital twin. And even if you want to, you could throw in there robotics to kind of make the interface work back from the digital into physical. So what I'm trying to describe here is that digital twinning is like a set of activities. It's not just a single thing. And when we're looking at an individual digital twin, just one digital twin, you can have a digital twin of assets or processes or systems. And that means it's not just a digital twin of a physical thing like a car or a pumping station or a wind turbine. You can also have digital twins of a process like a supply chain or like logistics, or digital twin of a company even, because that's a collection of processes. So you can make this two-way connection of lots of different things. So the reason for me saying that is I would like you to imagine the possibility of many different digital twins for many different purposes. Now, if we can imagine that, then we can see that it's never about one twin, it's about many. So now let me just paint a picture. If you can imagine a digital twin of a train, which is helping you to make better operational decisions, you can also imagine a digital twin of the track, because the track moves with the weather. You want to understand how the track performs. You can also understand a digital twin of the signaling. Now, in the physical world, all of these are connected up, obviously, because a train goes on the track past the signals. What we can also imagine is making a connection in the digital world. So to get one twin to inform another. And so now what we're talking about is making connections between twins. It's not just individual twins, but connected twins. And so what my slide would have shown, if it hadn't got magically deleted, is going back to the city. And so now you've got that city, this interconnected system of systems, and you can see dotted around it lots of different digital twins. But they're joined up, so they talk to each other. So you get the transport digital twin talking to the energy digital twin, which talks to the telecoms digital twin. Because in the physical world, they're connected. And now we're talking about making the connections in the digital world. And this isn't just theory. We've tested it. We tried it out. It's a really good program called CREDO, which stands for a climate resilience demonstrator. And we chose 3 sectors: the water sector, the energy sector, and the telecom sector. And we've shown pretty clearly that if you share information across those sector boundaries, you can make better resilience decisions. And that's what we need. Remember back in the days when I did the context, we were saying we've got these big challenges. We need things to be connected. Connected digital twins are a really key tool set to help us make those connections. So we really need to pursue that. The thing is, though, that it doesn't work unless we address this issue about data sharing. The whole thing which enables you to make an ecosystem of connected digital twins is a data sharing infrastructure. And so the thing I'd like to kind of get out there is that data sharing infrastructure is infrastructure. It's a 21st century infrastructure. It's not easy to see it, but it's really important. Because if we don't sort out that data sharing, then we can't get all the benefits that I've just been talking about. And if we're going to address these big system level challenges, fundamentally, we have to understand the systems better and then intervene more effectively. That's like the challenge. Okay, so that was digital twins. And I'll just do this very briefly. So we've already kind of covered that there's silos. Up on the screen there's a whole bunch more silos, talking about silos which are appearing between artificial intelligence and robotics and kind of people who are developing blockchain. And you've got some really clever people doing some really amazing stuff in silos. The idea of cyber-physical infrastructure is that there's a whole set of things which are kind of connected. And you know how I describe digital twins as making a connection between digital and physical worlds? Cyber-physical infrastructure is a whole set of technologies which help in making those connections. So the type of thing we're talking about, yes, it's digital twins, but also AI, also robotics, also the metaverse, which you will have heard about. All of these things are becoming real, but they're all in silos. And what we need to do is make the connection between them. Because if we can become masters of the digital world as well as the physical world, then we're really into a winning space. And I would suggest that's one of our biggest challenges in the whole of, in this century for us, is that we collectively have become really good at working in the physical world. We're actually great at it. We haven't yet taken over the digital world. It's not connected up. That's kind of like our challenge. And cyber-physical infrastructure enables us. Thankfully, we can imagine connections between them. And so there's been some consultation from government, you might have seen it, about national cyber-physical infrastructure. If you haven't, look it up. The Digital Catapult, the Connected Places Catapult, and the High Value Manufacturing Catapult are working together on bringing these together. And one of the key things, the kind of the fabric that enables the connection between these, again, is data sharing infrastructure. And in order to make data sharing infrastructure to work, we've got to address a few things. We've got to address the governance. We've got to address the semantics, which is all about getting the ontologies and taxonomies right. And we've also got to develop some shared software, some integration architecture to make it work. Thankfully, people are working on that just now. There's a demonstrator on the Isle of Wight run by the National Digital Twin Programme. If you're interested, you can check that out. So all of this stuff which looks like it's kind of futuristic sci-fi things, are actually, they're starting to happen now. The challenge is to federate them, is to get the connections between them. And in AI, I think AI has maybe had too much publicity over the last year. It's almost like it got invented last year and we're all fed up with it by now. But AI is kind of part of this picture. And you can see that in many ways the AI tide is rising. And it's taking over various different types of jobs. We know that. But what it should be doing is taking over the stuff that we don't want to do. And there is something that we in the industry have to do, is to kind of move up the hill to some cleverer stuff that humans are best at. Let AI do the rest. And just to kind of end with, you might like to have a look at that. I won't read it out. You've got it. As soon as I see somebody smile, I'll move on. Okay, I've got a smile. Digital twins. I mean, I'm sorry. You would think that somehow this would have worked. But you will remember now everything I said, didn't you? Look, car, connection between the physical and digital world, two-way connections. I'm going to go through this. All this technology which is connected. The technology which is not connected is the technology in my hand. Okay, here you are, individual digital twin. You put it in one corner. So you've got your generation, your transmission, your distribution, connected in the physical world, joined up in the digital world. And here's a city, digital twins all over the place, and we make the connection between them. And we say that sharing information helps address systems level challenge, and data sharing infrastructure is infrastructure. Isn't that amazing? I said all of that stuff without the slides. I'm done now, though. I'm not going to try any more technology, but I am open to questions if you've got time.
Is that working? Yes. So much data is being collected for regulatory purposes. I'm a lawyer that now runs a modular construction company. And you see tremendous standard data that you can draw upon for compliance with environmental directives. And when you talked about the 3 systems and the need to connect them, it really bothers me that regulators are spending so much time requiring individual provision of data for standard operations, like making a precast column. It should be enough data that you don't have to measure that every time if you follow a certain procedure to make it. And yet the regulators are saying, you collect it, you do this, or you use a database. And that's a private, closed system database you can't integrate. So I think the biggest challenge that you're talking about in bringing the systems and connecting it and providing the digital infrastructure you talk about is all these data silos that are either commercial or government, and meeting your privacy challenges, overcoming those as well to put together the data. We're finding that problem ourselves in our work.
Yeah, I think you put that very well. And I think that, you know, when I talked about organizations and institutions being in silos, regulators are an example of that. And you can kind of see the stovepipes kind of going through government departments, kind of ministers and regulators and arm's length bodies, you know, in transport or energy or water. And it's difficult to get that connection. But the connection between regulators that you raise, that, you know, that's a really important one. But of course it makes sense to be collecting data. That should be part of it. It's just that it should be connected. There should be this integration that you rightly mentioned. Oh, there's no questions, but one thing I would say is that if you are interested, please do reach out to me on LinkedIn. I'm very happy to kind of connect. And if there's anything that I've said that actually does make sense, yeah, we can follow it up. Particularly if you're interested in the system stuff, because I think that's the bit that kind of we have to change to make the rest of the stuff happen.